Question number 19. We are solving for 2 log 4 x minus 5 plus log 4 16 equals 3. Okay, so this is very similar to the problem we just did, question number 17. So if you watch question 17, this is similar, only we're in the reverse, right? So question 17, we were multiplying 2 log functions, and then we broke them apart into 2 adding logarithm expressions. Now in this case, we are adding 2 logarithm expressions and we are going to change them to a multiplication so we can solve for them. So the properties of logarithms allow us to change a logarithm or logarithmic expression to put it in a different form that will allow us to solve the problem easier. Okay, so the first step is we want to determine the domain. When we determine the domain, it can help us find those extraneous solutions. Okay, remember in class it was nice and easy. Once we got to the end, we were able to throw out one of those due to an extraneous solution. So that's going to be our first step. If you remember, if you watched a couple videos back, when we're finding the domain, we use the argument to find the domain. The argument is where the variable is. So in this problem, our argument is x minus 5. So we are going to find where x minus 5 is greater than 0. So we are going to, we now have our domain. So at the end, if we get a solution that is less than 5, we can throw it out because it would be considered extraneous. Okay? So we're going to rewrite our original equation, and we're going to rewrite it because we see one thing that we can change. And right away we can kind of change this exponent. So if you were to look in your textbook or you were to look in your notes, this is going to be the logarithm rule number 5. According to our textbook, and that's what we put in our notes. And so what that just says is we can move this exponent in front, or the exponent can be behind the argument. Regardless, you can rewrite it. Okay, so we rewrote that. Now we're going to use rule number 1. So rule number 1 says that if you have the same base, and we have base 4 here and base 4 here, that we can multiply m times n. Or in other words, we can multiply this argument by this number, right? We can multiply those. Okay? So I just rewrote the equation right here in case we didn't have it there. So we're just multiplying 16 times x minus 5 squared. Now the reason we could not have that exponent here is because that exponent would then have to be moved here. That's why rule number 5 comes first, because we're really only multiplying this x minus 5 squared, not the 16 squared. See how that'd be very different? Okay. Next, we want to convert to exponential form. Just wrote how you convert to exponential form, y equals log a to x. We rewrite that as x equals a to the y power. Okay, so this is our current log function. We want to write that in exponential form. Okay, so if we look here, okay, we have log a, so 4 is our a, that becomes our a here. Our y, okay, is what goes with the log. Okay, so that part is what it's going to be equal to, and the x is going to be is what it was equal to, and then our y is what our exponent is. So it equaled y, y here, that's our exponent, okay? So now we are simply trying to solve for x. I'm going to solve for x. So next step is we could take 4 to the third. 4 to the third is 64. So now our expression says 16 times x minus 5 squared equals 64. So now what can we do? We can divide by 16. So we're going to divide both sides by 16. When we divide both sides by 16, we're going to get x minus 5 squared equals 4. In order to get rid of this squared, we're going to take the square root of both sides, which would be x minus 5 equals plus or minus 2. So now, I just rewrote this. We are going to set the x minus 5 equal to both plus 2 and minus 2. So if we set that x minus 5 equal to 2, we're going to add 5 to both sides. We're going to end up with x equals 7. On this side, x minus 5 equals a negative 2. Add 5 to both sides, we end up with an x equals 3. Now, this is why that domain comes in so handy, because remember, our domain said that x needs to be greater than 5, and if it's not greater than 5, the solution would be extraneous. So we can get rid of the x equals 3, and we would be left with 7. So what you would need to do next is you would want to substitute in for 7 in for your original logarithmic equation to make sure that it works. I did so, and it does work. So our solution set for this problem would be 7.